find the antiderivative 1 over 2 minus cosine of x, notice that we're going to need substitution. U is equal to tangent of x over 2. If you solve for x using the arctangent on both sides, you're going to get x is equal to twice the arctangent of u. We need the dx. The dx is going to be the differentiated right side, which is twice over 1 plus u squared du. Right? Because the derivative of arctan is 1 over 1 plus u squared. And 2 is not touched, it's placed outside, which is still there, right? 2. So now we need the cosine. To get the cosine, we're going to need this equation again and take cosine of both sides, right? So cosine of x is going to be the cosine of this. Now cosine of this, we can use identity like we can use 2 cosine squared of arctangent minus 1. Right? So we need to find what the cosine of the arctangent is before squaring. Using the right triangle. First, what is the arctangent of u? Arctangent of u means the angle whose tangent is u. So let this angle measure be theta. So tangent of this angle is u, opposite over adjacent. But there's only u, right? But u over 1 is also u, right? So opposite is u and the adjacent is 1. So u over 1 is u. So the tangent of theta is u. So now what is going to be the cosine of theta, of this arctangent angle? The cosine is 1 over hypotenuse, adjacent over hypotenuse. The hypotenuse can be found by using the Pythagorean. 1 squared plus u squared, and inside the square root 1 plus u squared, right? 1 squared is 1, right? So we found the opposite side. So the cosine is 1 over square root of 1 plus u squared. So we have this part becomes what? This part becomes twice the cosine squared, right? So the cosine is 1 over square root 1 plus u squared. Now we square that, right? Because cosine square minus 1. So this happens to be what? This happens to be 2 over, the square root is gone, 1 plus u squared minus 1. Right? Which combined into a single fraction gives us 2 minus 1 minus u squared, right? So that's 1 minus u squared over 1 plus u squared, right? So that's the cosine of x in terms of the new variable u. Great, perfect. So now we can actually do work, now that we found all the correct substitutions. So the dx is what? The dx is 2 over 1 plus u squared. We'll put the du in the end. Times 1 over this. 2 minus cosine. Cosine is this. 1 minus u squared, 1 plus u squared du. We can take the 2 out. And then we're going to have 1 over 1 plus u squared times. Now notice that if you combine into a single fraction, the denominator of the denominator will be 1 plus u squared, which means that the 1 plus u squared will be where the 1 is, right? So 1 plus u squared can be written on the top. And the bottom, if you combine into a single fraction, the numerator will be this multiplying the denominator and then subtracting this part, right? So 2 plus 2u squared, right? This times that. And then minus, distributing the minus, and this is what you should get precisely, right? So simplifying, look what happens. 1 plus u squared is gone. This becomes 3u squared, right? Plus 1. 3u squared plus 1 du. And of course you can write it using the commutative property of addition, 1 plus 3u squared du. So notice that this looks almost like the arctangent antiderivative form, right? Because you can express this as 1 over 1 plus root 3 u and then square that du, right? Because if you square the square root of 3, you get 3 exactly, and u is squared as well, right? So this can be now used for the substitution. So let v is equal to radical 3u, dv is radical 3 du, right? So du is 1 over root 3 dv. Perfect. So what do we get? We get 2 over root 3 as a result. And then here we get 1 over 1 plus v squared dv. Perfect. So now the arctangent form is ready for you to find the antiderivative, right? 2 over root 3 arctangent of v plus a constant. 2 over root 3 arctangent of v in terms of u, which is radical 3u. Radical 3u plus a constant. And finally, 2 over root 3 arctangent of radical 3. Now what is u in terms of x? U was this guy, remember? Tan of x over 2, right? So tan of x over 2 plus a constant. This looks rather complicated, but this is the correct answer. If you got this answer, it means your work was complete and correct. Thanks so much for watching. Hope this was a lot of fun, and I'll see you in the next video.